Okay, welcome to the MGF 1107 Test 2 workshop, everyone. Um, I'm Noah Schmidt. I'm a math specialist in the TCC Learning Commons, and I'm going to be facilitating this workshop. And so what we're going to do is we're going to go over about maybe 17 questions that hopefully will reflect what you're going to see on the test for MGF 1107. And so the way this is going to work is each question, I'm going to give you a little bit of time to work on it on your own, maybe a minute and a half. It'll vary question to question depending on how long the question should be taken to complete. But we'll start with number one. This says, which of the following is the better investment? 4.8% compounded monthly or 4.7% compounded daily? So I'm going to give you guys about a minute and a half to try that. And the correct answer will be whichever of these investments is the better investment. So if you could take about a minute and a half on that, and then we'll go over it together, and then I'll see if there's any questions that anybody has. So thank you. All right, so there's a formula for calculating the effective annual yield. Okay, well, so I got a couple. If you want to put your answers into the chat, that would be great. We're going to go over this together. There's a formula for effective annual yield, and that formula is EY equals 1 plus R over N to the nth power minus 1. And so the effective annual yield tells you the amount or the percentage of interest for simple interest for 1 year. It converts a compound interest rate to the amount or the percentage of interest that you would get in simple interest for 1 year at that particular interest rate with that particular compounding period. So we have to determine which of these has the higher the effective annual yield, and that would be the better investment. So 4.8% would be 1 plus 0.048 over, and it's compounded monthly, so that'd be 12 for your N raised to the 12th power minus 1. And if we put that into the calculator and calculate it, I'm going to go ahead and do that right now. And I would get 0.049, which is basically 4.9%. So let's call it 4.9% because you'd want to multiply by 100 to change to a percent. For 4.7% compounded daily, we would have 1 plus 0.047 over. Now, for daily, you want to use the banker's rule, which is 360 as your n, and raise that to the 360 power minus 1. And if we put all that in the calculator, you get 4.8%. So the better investment is actually the 4.8% compounded monthly is the better investment. Okay. Does anybody have any questions on this problem? Okay. Here's the next problem. This says parents wish to have $80,000 in a college fund when their newborn is ready to attend college. If the account pays 6% compounded quarterly, how much money must be deposited to have the $90,000 available in 16 years, assuming that no other deposits or withdrawals are made during this period? So you've got to understand this is a one-time deposit that this person needs to make. And I'm going to just give you the formula and see if you can set this up. The formula for compound interest, single payment, is A equals P times 1 plus R over N to the NT power. So let me see if you guys can try to set that up and then calculate it. So I'll give you about, let me give you about a minute and a half on this one to try it, and then we'll go over it together. Thank you. Okay, so basically this is a one-time payment that this person needs to make. They want to have 80,000, but they want to determine how much they need to invest now so that they can have 90,000 available in 16 years. So 90,000 would be your A. That's the future value that the person wants to have. The P is unknown, and so you don't know how much you're going to invest now so that it accumulates to 90,000, but you know that it's 1 plus R. The interest rate is 6%, which as a decimal is 0.06 over, and they tell us that this is compounded quarterly, which is N is 4 on the denominator, and then that's raised to the 4 times T power. T is 16. Now what you want to do is you want to calculate this entire side Then hit the X to the negative first power button to take the reciprocal, and then multiply it by 90,000. That's how you would calculate this on your calculator. You do everything on the right, so you'd want to do parentheses 1 plus 0.06 over 4 to the, this 4 times 16 is the 64th power, and that gives us a certain number, which then needs to be, then you just press your X to the negative first power button, which is your reciprocal button, and then multiply it by 90,000. And that would give me $34,706.90 would be how much they would need to invest today or now, and so that it would accumulate to 90,000 within 16 years. So does anybody have any questions on this problem? Okay. Here's the next problem. This says a shoe store owner needs $2,500,000 in 10 years to expand her business. How much should she invest each month if the investment can earn a rate of 9.9% compounded monthly? So this problem is an annuity. It's going to be a future value of an annuity, because an annuity has a series of payments, not just a one-time investment, but a series of payments. And if you're interested in how much you're going to have in the annuity, from the annuity in the future, that's a future value. And the formula for future value of an annuity is A equals the payment, PMT, times bracket times 1 plus R over N to the NT power minus 1 close bracket all over R over N. And so I'm going to get everybody to try to see if you can set this up and calculate it on your calculator. I'm going to give you about 2 minutes on this problem, and then we'll go over it together. Thank you. All right, so the $2,500,000, that represents the future value of the annuity, because that's how much the store owner needs to have in 10 years. So you're going to put that in for your A. And so it looks like this, and the payment is the unknown. They want to know how much this person needs to invest each month. And so now you have a bracket with a parenthesis 1 plus R is 9.9%, but as a decimal, that's 0.0099 over. If it's compounded monthly, that's basically a 12 for your N. That goes on the denominator. This is raised to the NT power. So this is 12 times 10, because 12 is monthly, and there's 10 years for your T. And then this is subtracted by 1. And this is all over parentheses R, which is 0.099 over N, which is 12. And so basically, you, like we did on the previous problem, you want to calculate all this whole side by putting it in just like it is on the calculator. And once you do, then you please ignore the vertical lines. Those are just the drawing pad kind of does that without me telling it to. But after you calculate this whole right side, you then, because you're trying to solve for the payment, you want to press the X to the negative first button, which is the reciprocal button, and multiply it by 2,500,000. So if I do all that on the calculator, the 12 times 10 is to the 120 power. Okay, so you do that whole right side, and then you press the X to the negative first button and multiply it by 2,500,000. And I end up with $12,274.40 would be the monthly payment that would generate that amount in 10 years. All right, so does anybody have any questions? Okay. All right, so let's try this problem now. This says, suppose you borrow $400 from a friend and you agree to pay back $675 in 7 months. Determine the loan's annual simple interest rate rounded to the nearest 1/10 of a percent. So you're going to need the simple interest formula, and that formula is, you're going to need the future value of simple interest, which is A equals P times 1 plus RT. You're going to use that formula on this problem. I'm going to give everybody about a minute and a half, and then we'll go over this problem together. Thank you. All right, so what we know on this problem is that we're borrowing $400, that's the P, and that we're paying back $675, that's the future value, A. This is a loan, basically. Now, R is the unknown. We don't know the simple interest rate as a percentage. So we're going to say parentheses 1 plus R is unknown. And the time is 7 months, but the 7 months needs to be in years, which is 7 out of 12, 12 months in a year. And so we're going to solve this for R. And the first thing I would do, rather than distributing the 400 into the parentheses, I would divide by 400 on each side to cancel it out. And if you take 675 divided by 400, you end up with 1.6875 equals 1 plus R times 7/12. But basically, you don't need the parentheses anymore because there's nothing attached to the parentheses in front now. But you can now solve for R, so you have to cancel the 1 out. You're going to go ahead and subtract 1 from each side. And that gives us 0.6875 equals R times 7/12. But now if you're solving for R, if you want to cancel out the 7/12, which is a fraction, you actually want to multiply by the reciprocal of 7/12, which is 12/7. The reciprocal, multiplying a fraction by its reciprocal cancels it out. So you get R by itself. So you multiply by 12/7 on the other side. Over here, the 7's cancel, the 12's cancel, and you have R equal to 12/7. So 12 divided by 7 times 0.6875. And so if I put this in my calculator, I end up with 1.1786, but we need to have that as a percentage, and the way to convert a decimal to a percentage is to multiply by 100. And so if we multiply that by 100 and round to the nearest tenth, we get 117.9% interest rate would be the interest rate on this particular loan. Okay, does anybody have any questions? Okay. Here's the next problem. This says Mary can afford car payments of $225 a month for 4 years. She borrows the money at 6.2% compounded monthly. What price can Mary afford to buy now? So basically, this is going to involve an annuity, because anytime you have a loan, a car loan, a mortgage, or anything like that, you have an annuity, but it's the present value of an annuity that you use. That's the formula you use for a car loan or a mortgage. So that formula is P equals PMT times bracket 1 minus parentheses 1 plus R over N to the negative NT power over R over N in parentheses. So let me see if you can use that formula with this in this problem. I'm going to give you about, let's say 2 minutes on this problem to set it up and try it, and then we'll go over it together. Thank you. All right, so what we know on this problem is we don't know the P. That's the present value, which is how much is being borrowed now by Mary. So P equals the payment, which is $225 a month. They give us that, times bracket 1 minus parentheses 1 plus R is the interest rate, 6.2% compounded monthly. So it's, as a decimal, that's 0.062, but it's compounded monthly. We put that over 12. And then raise this to the -4 times 12 power, because it's monthly is your N equal to 12, and your T is 4 years, which is 4. And then we close the bracket off, put this over R, which is 0.062, over N, which is the 12 months. And we just have to put this into the calculator and see what we get. And so I ended up with $9,543.27. So $9,543.27 as my result there. So does anybody have any questions on this problem? Okay. Here's the next problem. This says determine the effective annual yield of an account paying 4.75% compounded daily. We're going to round your answer to the nearest hundredth of a percent. So just a reminder, the effective annual yield formula is EY equals parentheses 1 plus R over N to the N power minus 1. So let me let everybody try this problem on your own. I'll only give you about a minute on this particular problem, and then we'll go over it. It doesn't take as long as some of the other problems. So if you could take about a minute, and then we'll go over this problem. Thank you. All right, so we want the effective annual yield of 4.75% compounded daily. That's going to be 1 plus R is 0.0475. This is all over, and if it's daily, we're going to use the banker's rule for the number of days. That's going to be 360 days, which will be your N on the denominator. This is going to be raised to the N power, which is 360 minus 1. And if we put this into the calculator, we end up with 0.0486, but you need to have this as a percent, and so to change from a decimal to a percent, we're going to multiply by 100, and if we do that, we end up with 4.9% would be the effective annual yield. because you multiply this over, you got to round to the nearest. Actually, they want it to the nearest hundredth of a percent, so that would be 4.86. So 4.86% would be to the nearest hundredth. So does anybody have any questions? Okay. Here's the next problem. It says you deposit $250 into an account every month for 35 years. If the interest rate is 4.4% compounded monthly, determine the amount of money in the account after 35 years. We're going to round to the nearest cent. So you're going to need the future value of an annuity, because it is, the deposits are made every month, which is a series of payments, but we're concerned with how much money is going to be in the account after 35 years. That's future value of an annuity. And just as a reminder, the formula is A equals PMT bracket 1 plus R over N to the NT power minus 1 bracket all over R over N and the denominator in parentheses. So if you could go ahead and set this up and try to calculate it, I'll give you about 2 minutes and then we'll go over it. Thank you. Okay, so the $250 that's deposited into the account every month, that's you're going to be your PMT, which is the payment. A is unknown. We don't know how much is going to be in the account after 35 years. Then this is going to be bracket parentheses 1 plus the R is 4.4% as a decimal, which is 0.044 over N. This is being compounded monthly, so 12 will be your N on the denominator. This is raised to the N, which is 12 times T, which is 35 power. Then we close off the bracket, put this over R, which is 0.044 over N, which is 12. And we just have to put this into the calculator. We don't need the reciprocal button. So this is going to be 250 times parentheses And so you just want to kind of put it into the calculator as it is. Now, if you multiply 12 times 35, you get 420. So that should be your exponent. And so I end up with 317,145.76. Did anybody not get that or have any questions? Okay. Actually, I made a mistake in the when I put it in my calculator here. I'm gonna redo it. I didn't subtract the 1 there. Sorry about that, guys. So it's actually $248,963.94 would be the result there. Okay. Does anybody have any questions? Okay, here's the next one. This says find the interest earned on an investment of $4,500 at 4.1% simple interest for 180 days. When you're using simple interest and you are finding the amount of interest earned, you only need the formula I equals PRT, because that tells you how much interest is earned in simple interest. So let me give you about a minute on this particular problem to try it on your own, and then we'll go over this one together. Thank you. All right, so in this case, the I is unknown. We don't know how much interest is being earned, but the P is $4,500, and it's invested at 4.1%, which as a decimal is 0.041. So I apologize for these vertical lines. And then 180 days, but that needs to be in years. So to make it, put it in years, you take the 180 days and divide it by the number of days in a year. But in the banker's rule, you use 360 for the days in a year. And so then we're going to put all this in the calculator and see what we get. So when we put all this into the calculator and calculate it, we end up with $92.25 as the amount of interest earned in that situation. Okay, so does anybody have any questions? Okay. Here's the next problem. It says, in order to pay for a bathroom renovation, a couple takes out a simple interest loan for $20,000 for 6 months at a rate of 4.92%. How much will they have to pay back in 6 months? You're going to need to use the simple interest formula for future value. A equals P times 1 plus RT. So I'm going to give you about a minute and a half to try this particular problem, and then we'll go over it together. Thank you. All right, so basically, the couple is taking out a loan of $20,000. That's actually going to be the present value P. So you have 20,000. Your A is how much is going to be paid back in the future. And this is going to be 1 parentheses 1 plus R is 0.0492. And then it's in 6 months, which is 6 months out of 12 months in the year. And so if we put all that into the calculator, we end up with $20,492. And so anybody not get that or have any questions? All right, so let's move to the next problem. Okay, this says Joe is buying a duplex for $125,500. He makes a down payment of $25,100. If he has obtained a 30-year mortgage at 5.8% compounded monthly with no points required, how much is his monthly mortgage payment? Well, so we're going to go ahead and do this one together. I'm not going to really give you any time to go on your own and work it on your own before we go over it. Let's just go ahead and go over this one. But the first thing is Joe is buying the duplex for $125,500. That's not how much is being borrowed, though, because he's making a down payment, and the down payment is money that's being paid up front, which affects how much money is being borrowed. So you take the amount that he bought the duplex for, $125,500, and you subtract off the down payment. And that would tell you how much money is being borrowed. So if you take 125,500 and subtract off 25,100, you end up with $100,400 as the amount borrowed. Now, when you're dealing with mortgages, the formula to use is the present value of an annuity. And that formula, I'm going to remind you, we've used it a couple times, one time, I think. It's P equals PMT times bracket 1 minus parentheses 1 plus R over N to the negative NT power all over R over N. So on our particular problem, we want to say P equals, well, actually P is known. So P is actually how much is being borrowed. So we're borrowing 100,400. That's going to go in as your P, and it's the PMT, the payment, that's the unknown. So you put in 100,400 equals PMT, which is unknown, bracket 1 minus parentheses 1 plus R is 5.8%, which is 0.058 over monthly is 12. This is raised to the negative. Now, most mortgages are either 15 years or 30 years. So if it's 30 years, 12 times a year, that your N times T is going to be 30 times 12, which is negative. So it's going to be negative 360 as your exponent. This is bracketed and then all over R, which is 0.058 over N, which is 12. So now we're going to put, like I emphasized on previous problems, we want to put this whole side into the calculator and then take the reciprocal button, x to the negative first power, and then we'll multiply that by $100,400. And so if we do all that, we're going to start out by putting the whole right side in to the calculator. And so when we do all that, we get a certain number, which then you press your reciprocal button, your x to the negative first power button, and multiply that by 100,400. And when you do all that, you end up with a payment, with a monthly payment of $500, $589.10. Okay, so does anybody have any questions? Okay. This is another problem with the effective annual yield and trying to determine which is the better investment. So I'm going to give you about a minute and a half on this to try it on your own. And on this one, since we've already kind of gone over this one, I'm going to basically just write the solution up here and then just give you an overview rather than explaining step for step how to do it, because this one I want to kind of give you a chance to work on your own because we've already done an example just like it. So if you could try this for about a minute and a half, and then I'll start, while you're doing that, I'll put the solution up and let you check your solution and see if there's any questions. Thank you. So I got the better investment is the 5.8% compounded monthly because it's got a higher effective annual yield than the 5.6% compounded daily investment. So does anybody have any questions on this problem? Okay. Here's the next problem. This says if you want to have $7,000 in 4 years, find the amount you would need to deposit now at a simple interest rate of 6.5%. So this is going to be a simple interest formula. Future value, you're going to use A equals P times 1 plus RT. And so if you could go ahead and try this for about a minute and a half, and then we'll go over it together. Thank you. Okay, so on this particular problem, it says if you want to have $7,000 in 4 years. So 7,000 is the amount that's in the future. And so that's going to be your A. Your P is unknown. And so then this is times parentheses 1 plus R is 6.5%, which as a decimal is 0.065 times your T is 4 years. And so you're going to need to do this entire right side, and then you can raise this, or you can use your x to the negative first power button as your reciprocal and multiply it by 7,000 on the other side so that you can solve for P. And so if we do all that, we get, I'm going to put this into the calculator. And so we calculate that P is $5,555.56. Okay, so does anybody have any questions there? Okay, here's the next question. This says a monthly mortgage payment on a 15-year mortgage is $1,784. The amount of the original mortgage was $225,000. If the count is kept the full 15 years, how much interest will be paid? So you don't need any real formulas for this. Well, there is kind of, but it's more not a formula we've used regularly so far. You want to determine the amount of your payments in the mortgage because you're having to pay the mortgage back. You're having to pay the amount you borrow back with interest. So you want the amount of your payments, and you want to subtract by the amount borrowed. So how do you know how much you paid? Well, you paid $1,784 a month, and you paid that 12 times a year because it's monthly payments, and you did it for 15 years. That would tell you how much you actually paid. And so if we do all that, we end up with $321,120 minus the amount of the original mortgage, which was $225,000. And when you subtract there, you end up with $96,120 as your amount of interest. So does anybody have any questions on this problem? Okay, here's the next problem. This says Javier and Ursula are buying a house for $210,000. They're making a 20% down payment and have obtained a 30-year mortgage at a fixed rate of 5% compounded monthly. Find the down payment. So the down payment is 20%. Let me give you about a minute to see if you can try this on your own, but then there's really not a whole lot of steps to it. So I'll give you about a minute to try it on your own, and then we'll go over it together. Thank you. Okay, so the down payment is just 20% of $210,000. And so 20%, to find that of $210,000, you just take 0.20 times 210,000. And when we do that, we end up with 42,000. So that's how much is the down payment. The down payment, then the next question says find the mortgage amount. Well, the mortgage amount is basically the amount that the house was bought for, which is 210,000, minus the down payment that's being paid up front, is the amount that's being financed in the mortgage. So if you take the 210,000 and you subtract off the $42,000 down payment, you end up with 168,000 as your mortgage amount, the amount that's being borrowed. All right, so does anybody have any questions on this problem? Okay. All right, so here's another problem. This says you've just inherited $20,000. You can invest it at 4.5% compounded semi-annually. Find the future value of the account and the interest earned if you invest the money for 12 years. So this is actually going to be a compound interest, but it's only a one-time payment. So because it's a one-time payment and not a series of payments in an annuity, then this formula is going to be A equals P times 1 plus R over N to the NT power. So let me let you try this problem for about a minute and a half, and then we'll go over this problem together. Thank you. Okay, so the $20,000 that was inherited is the P, the present value that's invested today. And this is parentheses 1 plus R, which is 4.5%. That's 0.045 as a decimal over. Now this is compounded semi-annually, so your N is going to be basically 2 twice a year. And then this is going to be raised to the 12 is the T times the N, which is 2, so 12 times 2 power. And so we just have to put all this into the calculator. We don't need the reciprocal button because it's all on the same side. So if we put all this in the calculator, we end up with $34,115.33. And so that would be your future value A. So does anybody have any questions on this problem? Okay. All right. Now, so this says how long will it take to double $1,000 at 4% compounded annually? Now, the doubling time for an investment, there's a rule called the rule of 72. The rule of 72 says that if you take 72 divided by the effective annual yield as a percentage, not as a decimal, but as a percentage, you'll get the amount of time that it takes for an investment. It doesn't matter how much the investment is. It'll double it depending on what the effective annual yield is. So whether it's 1,000 doubling to 2,000 or $1 doubling to $2, the doubling time is only dependent on the effective annual yield as a percentage. And so what's the effective annual yield for 4% compounded annually? You take 1 plus R, which is 0.04, over N, which is, but if it's compounded annually, your N is 1. And then your exponent, you're raising this to the nth power, which is 1. So all this really means, and this is going to be subtracted by 1, all this really means is that you have 4% as your effective annual yield, and that was the same as the interest rate because it's compounded annually. So if we want to calculate the doubling time here, we just have to compute 72 over 4, which is the effective annual yield as a percentage. And so 72 over 4 is just 18. So this would take 18 years to double the investment if it was 4% compounded annually. So does anybody have any questions on this problem? Okay. And we've got one more problem here. This says an amount of $750 is invested at 4.6% compounded quarterly. The future value of the account in 8 years is $1,081.36. How much interest is earned? This is just a straightforward, it's just a one step. I want to give you about a minute to see if you can determine how you would do this on your own, because a lot of what's going to happen on your test is you're going to have to determine what the process is going to be. You know, the calculator is one issue, but then you have to determine what formula to use and what process to use to determine whatever they're asking you for. So let me see if you can try this for about a minute, and then we'll go over this one together. And this will be our last problem. Okay, so basically if the initial investment is $750 and the future value is $1,081, essentially the person invested $750 of their own money, but now their investment is worth $1,081.36. Well, the difference in those two amounts is the amount of interest earned. So this is all we really need to do on this particular problem, is just to take $1,081.36 and subtract off $750. And so you have $331.36 as the amount of interest earned on this particular problem. So with that, that's pretty. Does anybody have any questions on this problem right here? Okay, so that's the end of our PowerPoint. Does anybody have any questions about anything we went over, or just the learning comments, how you can receive tutoring or anything? Does anybody have any questions?
Is weekly tutoring offered?
Well, we actually offer, we're open, our hours of operation are Monday through Thursday, 7:30 in the morning to 7:30 p.m. And then on Friday, we're open from 7:30 in the morning to 5 p.m. But you just have to, let me share my screen here and show you how you can go go about the process of getting tutoring, because you just have to sign in, and you can either, if you're coming to the Learning Commons, you can be here at the Learning Commons, or you can get online tutoring as well. But either way, this is where you'd go to sign up for tutoring. You just go to the TCC website, click resources, and go to the Learning Commons, click on Learning Commons, and you see where it says tutoring. So you can also click virtual resources too. We have a lot of handouts and videos and resources you can download there. The tutoring though, if you go to tutoring and you want math tutoring, there's different subjects for tutoring. But if you just click, if you, regardless of which subject, this is the subjects that we tutor, regardless of the subjects, you just click here to access Eagle Q, and it takes you to a place where you just sign in. And someone will contact you when you sign in, and they'll ask you, are you here at the Learning Commons for face-to-face tutoring, or are you wanting to be tutored online? But once the tutor is ready to summon you, then you receive a text, and if you're getting tutored online, they'll send you a link to click to get online to the tutoring session. And if you're at the Learning Commons, the tutor, he or she just finds you and tutors you at the Learning Commons. So does anybody else have any questions? All right, well, I hope you benefited from this review. I hope you do well on the test, and thank you for coming to the review. And please feel free to email me if you need any assistance or have any questions about anything. And we have the workshop that's going to be on, I believe, Monday, is the same thing. We're going to be going over the same thing. So I'm going to also send the recording out, planning on doing it this afternoon. So if you want to see the recording again, I'll plan on sending you the recording by email. It'll be to your Outlook email. And so you're certainly welcome to come to the workshop on Monday. It'll be the same PowerPoint that we'll go over, but just wanted to let you know, some people want to know what we're going to be doing on the second workshop. It'll be basically the same workshop for those that couldn't make it today. But both recordings, I'll plan on sending the recording. I'm not planning on recording the Monday session, but because it'll be redundant, but you'll have this recording no matter what. So, all
Okay,
right.
thank you.
All right. Well, if anybody has any questions, please feel free to stick around. Otherwise, thank you for coming, and I hope you have a wonderful weekend.